Welcome back to China Tech Weekly and to today's Explainer, where we are objectively breaking down a massive structural shift that is happening, quite literally right now. You might be wondering, why does this matter to me? Well, because the global hardware supply chain, the exact same one that powers every single device in your home, every app on your phone, and every AI tool you use, is being completely rewritten. Driven by shifting global trade dynamics, we're watching the incredibly accelerated construction of a fully independent, vertically integrated computing and energy infrastructure. Today, we're diving into the news of the past 7 days across 11 key Chinese hardware companies that are practically rewiring how technology gets made from the ground up. So can a nation really rebuild the entire global tech stack in just a few years? Let's jump right into this by asking what is arguably the defining macroeconomic question of our time. With tightening trade restrictions and just a massive influx of coordinated capital, a parallel tech ecosystem is rapidly maturing. We're talking about a highly coordinated effort to swap out foreign technology across absolutely critical systems, from national banking right over to telecommunications networks. It's a fundamental rewiring of the technological world order. Think of it like building a house. We are going to build a completely independent computing ecosystem right here, from the ground up. We'll start at the atomic level with the foundries that actually bake the chips. From there, we'll move up to the silicon that processes all the data. Then we'll connect the whole thing together with high-speed networks. And finally, we'll plug this massive system into the power grid. It's a true top-to-bottom stack. Here is our roadmap for the Explainer today. 1. Fab equipment and foundries. 2. Compute hardware and silicon. 3. High-speed interconnects and connectivity. And 4. Grid storage and energy. Starting with Section 1, Fab equipment and foundries, the absolute foundation. We're talking about the multi-billion-dollar manufacturing facilities and the ultra-precise equipment required to bake the silicon. Okay, the crucial takeaway here is that Nora Technology Group has just broken a really long-standing fabrication monopoly held by the US and Japan. See, for advanced chips, standard plasma etching uses these highly energetic ions that can actually damage the super delicate underlying layers of the silicon. It's kind of like carving a fine sculpture with a sledgehammer. Well, Nora just introduced a 12-inch gas cluster ion beam, or GCIB system. So instead of harsh plasma, it uses nanometer-scale clusters of gas atoms to achieve atomic-level precision. This enables those extremely smooth, pristine surfaces you absolutely need for sub-7 nanometer logic nodes. It effectively localizes a massive bottleneck in advanced chip fabrication. And the broader consolidation happening right now across the sector is just as impactful. Advanced Microfabrication Equipment, or AMAC, has successfully verified its proprietary 14-nanometer dry etching tools on actual production lines. And guess what? That led to an incredible 197.2% jump in their first quarter profit. Huge, right? Meanwhile, China's largest foundry, SMIC, just finalized a massive 40.6 billion yuan asset restructuring. Backed by the state's National Integrated Circuit Investment Fund, often just called the Big Fund, SMIC issued shares to acquire full 100% ownership of its 12-inch Beijing foundry. They are aggressively locking down their manufacturing capacity to meet soaring domestic demand. Moving right along to Section 2, Compute hardware and silicon, the processing brains. Once you can actually manufacture the chips, you need them to perform incredibly complex tasks. We've got 3 major players essentially dividing and conquering the specific demands of AI architecture right now. First up, Hygon is tackling general computing, recently debuting their C86-5G CPU. To really put this in perspective, this thing boasts a massive 128 cores and 512 threads. That means it can handle a truly staggering amount of parallel processing all at once. Then you have Cambricon, and they're locking down the heavy AI training workloads, reportedly securing a massive 200,000 unit pre-purchase order from ByteDance. And finally, Shanghai Iluvatar Core X is stepping up to handle AI inference, which, if you remember, is the actual business of answering user queries once a model is already built and trained. To give you a sense of the sheer, massive scale of this domestic adoption, consider this $1.7 billion figure. China Telecom recently awarded a massive server tender for that exact amount. They ordered 40,000 servers to act as the backbone for their infrastructure. But here is the real kicker. 71% of that budget went to suppliers utilizing homegrown Hygon and Huawei Kunpeng ecosystems. It is a direct swap away from foreign processors, handing homegrown silicon ecosystems a major, major win, funded by state carrier capital. So let's see how all of this builds into financial reality. Cambricon recently saw its stock absolutely skyrocket, briefly nearing a 1 trillion won market cap valuation. Now, while they denied specific rumors about exactly which chip models were shipping, honestly, their financial results speak volumes. They posted triple-digit growth in Q1. Revenue was up almost 160%, and net profit jumped 185%. The market is aggressively pricing in this insatiable demand for domestic AI training hardware. We are also observing a really massive pivot toward inference hardware right now. As of March, China is consuming a staggering 140 trillion AI tokens daily. Just to put that into perspective, that is the equivalent of processing millions of books worth of data every single day. No way, right? Well, to handle this, Shanghai Illavitar Core is in advanced talks to supply at least 50,000 of their Zekai GPUs to ByteDance. But what makes Illavitar so incredibly competitive is their software. They built a proprietary compiler that is deeply compatible with the CUDA ecosystem. For a little context, CUDA is NVIDIA's dominant software platform. So Illavitar's compatibility means operators can just migrate their existing AI code to domestic silicon without dealing with expensive, time-consuming rewrites. It is the ultimate plug-and-play solution. Okay, Section 3. High-speed interconnects and connectivity. Because, let's be real, all those incredibly powerful chips are totally useless if they can't effectively talk to each other. Montage Technology is actively eliminating systemic data bottlenecks as we speak. They are now sampling their Gen 6 DDR5 clock driver to global memory manufacturers, and it pushes data transfer speeds to a blistering 9,200 megatransfers per second. Think of it like taking a massive digital highway and widening it by 15%. It ensures that the incredibly fast processing chips we were just talking about aren't suddenly starved for data traffic while waiting in a digital gridlock. To manage this huge optical interconnect supercycle, GigaDevice is deploying highly specialized microcontrollers. Instead of just a lazy one-size-fits-all approach, they've released two parallel tracks. One is built for the extreme demands of high-bandwidth data centers, managing vast amounts of data with virtually zero delay. The other is optimized for low-speed, cost-sensitive access networks. Working together, they basically act as the essential traffic controllers for the entire network, offering a completely localized management solution. And this networking boom, it is directly funding global expansion. Zhongji InnoLight, which is the world's largest producer of optical transceivers, saw such strong demand recently that they actually raised the target for their upcoming Hong Kong listing to an eye-watering $7 billion. Meanwhile, fierce competitors like Eoptolink are aggressively expanding their intellectual property for advanced pluggable optical modules, which are essentially the physical cables and laser components that actually transmit all this data. Ultimately, the hardware required to link thousands of GPUs together is creating a massive financial supercycle all of its own. And finally, Section 4, Grid Storage and Energy. We've reached the last layer of our stack. This is the massive utility-scale energy required to plug this entire AI ecosystem into the wall. 15,000. This staggering number of charge cycles represents serious grid longevity. CATL recently debuted their Tenor sodium-ion battery energy storage system. In practical, everyday terms, hitting 15,000 cycles provides a reliable, field-validated lifespan of up to 30 years for utility-scale grid storage. We're talking about generational infrastructure here, the kind that can power entire facilities for decades. And the technical features on this thing are absolutely remarkable, representing a major insight into the global supply chain. By shifting to a sodium-ion base, CATL is completely removing its reliance on lithium. Each fully modular setup provides over 30 megawatt-hours of capacity. And get this, it maintains over 92% of its power in extreme freezing temperatures of -20 degrees Celsius. Plus, it features an intrinsically safe, fireproof design. It's exactly the kind of robust, community-friendly infrastructure needed to stabilize electrical grids that are constantly balancing fluctuating renewable energy with these massive, power-hungry AI compute loads. So as we've seen through the developments of these 11 companies over just the past 7 days, a parallel tech ecosystem is rapidly maturing. From atomic-level etching machines and 128-core CPUs, to high-speed optical networks and 30-year grid batteries, a completely vertically integrated stack is emerging right before our very eyes. It really leaves us to wonder, if this structural market shift successfully redraws the global technological map, who ultimately controls the future of international innovation? Thank you so much for joining me for this explainer. I hope it gave you a really clear picture of the massive shifts happening right now. Catch you next time.